Hey, Chemisters, this is Mrs. Vandeloy bringing you 9.2 common reactions involving aldehydes and ketones. So I'll be perfectly honest with you, there are many, many different reactions involving these aldehydes and ketones. We're only going to do a couple of them. I'll save the rest of them when you take college organic and see how much fun that will be, all right? But we're going to start off with oxidation of alcohols. They do require a catalyst and heat. Notice I capitalized and heat. So when we dealt in chapter 7, which we talked about alcohols, that we said if you can make water, you will make water. But we're not going to here, okay? This is not simply a substitution. This is an oxidation. So we're going to have heat involved. And what did you think of with heat? Oh yeah, it's elimination. We normally do get a double bond, and we do get a double bond here, okay? So what am I going to make? Well, oxidation of primary alcohols will produce an aldehyde. Now this carbon is actually not classified as primary. It's actually classified as a methyl. There are no other carbons. This carbon right here is primary because it does bond with one other. That's why I call it primary. So what happens? Well, it's going to be oxidized. What's going to be oxidized? The carbon is going to be oxidized, okay? Well, here's what the structure kind of looks like, all right? So this carbon is single bonded to this oxygen. But what happens is that we're going to produce an aldehyde. So something called the oxidation number of carbon is going to change. It's going to go from a, -2 to a 0. So the oxidation number went up. Well, something has to be reduced in the meantime, and it's the hydrogen goes from a +1 to a 0. Now, am I going to ask you for all that? No, I don't. I don't know if you even know what oxidation reduction means. Some of you do, some of you don't. But I just want to show you this. So here's carbon with 4 bonds, right? Well, when it becomes an aldehyde, that takes up 2 bonds. So there's only more room for 2 hydrogens. So where'd those other 2 hydrogens go to make H2? Okay, so something else to consider, why isn't it H plus? That's pretty common to make H plus, and the answer is 2 reasons. Number 1, carbon had to be oxidized, so hydrogen had to be reduced. If it were H plus, hydrogen didn't reduce. The other reason is that this side is neutral. There is no charge. So this side has to be neutral and has no charge. So if I wrote 2 H pluses, that has a charge. All right, so the main point here is if you have an oxidation of alcohols to produce an aldehyde or ketone for that matter, you're going to make H2, not H plus. All right, so what is this? This looks like propanol. And so if I were to add heat and a catalyst, what do you think I'm going to make? Everyone, you can do it. There we go. We made propanol, I can say it. And what else? What shouldn't I forget? H2, that's right. Okay, let's see what happens if we have secondary alcohols. All right, so oxidation of secondary alcohols are going to produce ketones. All right, so where is your OH? Well, it's on the second carbon, isn't it? So guess what? You made 2-propanone. What else do you make? And water. Cyclohexanol looks like this. I'll put it over here. All right, what are you going to make? Take a wild stab. You're going to make cyclohexanone and hydrogen. So my question is, why don't we have the letter C here of oxidation of tertiary alcohols producing ketones or whatever? Well, the problem with a tertiary alcohol is that there is no hydrogen on the next carbon, if you will, all right, or on that carbon to help come off, all right? So the hydrogen is right here. That's the hydrogen that comes off with this hydrogen. If you had a tertiary, there is another hydrogen on that carbon to make that work. So there is no oxidation of tertiary. Let's see what 9.6 is all about. So we're going to do a nucleophilic addition, think about that, to a carbonyl group. Okay, so nucleophilic addition, not substitution, not elimination, addition to a carbonyl group. And guess what? Here, you do make water. All right, so let's look at this Roman number 1. If we have a weak nucleophile, either an alcohol or water. All right, so let's kind of look through this. Because an unshared electron pairs on the oxygen atom, the carbonyl compounds are weak Lewis bases. They can be protonated by an H+ acid catalyst. This produces a positive charged oxygen, which then can create the carbocation. The positive carbocation can attract the weak nucleophile. The product is positively charged, and H+ can fall off the weak nucleophile, leaving the neutral product. This is what makes it an acid catalyst. What I am describing in 1, 2, 3, 4 is a mechanism. All right, it's a mechanism. And to be completely honest, I thought this was going to be more difficult doing it on a video than in person. I'll just say it like that, okay? The mechanism is pretty complex here. So what I decided, because I'm making a video, and again, I'll be very honest, it is going to be a pain in the neck to try to type all this stuff out. I'll just say that. I figured I'll let your college professor show you this mechanism. All right, how's that for a plan? I think it's a great plan. All right, so what is it that I do want you to know? All right, so that just know that the final product will have the 2 ether groups on it. Remember, this is an addition, isn't it? So let's see how this works. Okay, so in my step 1, I have, I'm just using benzaldehyde and ethanol. So my step 1 is that I'm going to break the double bond. I'm going to put the carbocation on there, if you or create a carbocation. But the point is, the H here, all right, is going to be attracted to this O, all right, and then the O is going to continue with the carbon group, all right. So I have as an intermediate an ether and an alcohol. But what if I have step 2? All right, here's my step 2. I'm going to take that same alcohol, and now what? I have an alcohol here, and this is where if you can make water, you will make water. So this alcohol and that alcohol are going to join up and make water, and so I end up with a 2 ether group. And so that's what I said here. Just know that the final product has 2 ether groups in it. So your intermediary there, your intermediate, will have an ether and an alcohol. All right, and then when you do it again, the alcohol and the alcohol makes another ether. Okay, so for example, if I just want to go to the end, all right, so if I want to have ethanol and lots of methanol, okay, so what am I going to do? So here's my ethanol, here's my methanol, okay, so what am I going to make? Well, I'm going to make my end products. Just jump to step 2. I'm going to have my 2 ether groups, all right, and my water, okay, and my water. By the way, how am I going to name this? Oh, let's think about that real quick. How am I going to name this? I have 2 ether groups. Think about it. When you're ready, I'll give you the answer. I got 1,1-dimethoxyethane. All right, do you see that? They're both on the same carbon. So it's 1,1. I have 2 methoxy groups, and then I have an ethane. There you go. All right, you know this was coming. All right, I have one more example for you. What if I have, there it is, butanol. I had to say it right. And excess phenol. All right, so what are you going to do? So go ahead and try this on your own and see what you get. Pause this for me. Now I drew my, I'll say it right, butanol kind of oddly, if you will. I put the O over here. Well, again, that's the O that's going to be doing the reacting, right? And here's my phenol. All right, I'm going to take excess. I need 2 of them. So remember, I'm going to end up with 2 ethers. All right, and I did make water. All right, any ideas how to name this one? Let's pause it and come up with your answer. Well, this is what I got, 1,1-diphenyloxybutane. Okay, that looks like fun, doesn't it? Let's go to the next page. All right, so here we're going to actually show you the two steps. So because I don't have excess methanol, I have only one methanol. So I don't end up with my two ether groups. Do you remember what I end up with? One ether. For that, I end up with one ether and one alcohol. All right, so I end up with, I think this. There you go. So I have one ether and one alcohol. By the way, how do I name this? Good question. I have one methoxy, one butanol, OL. Okay, so now what? What's my final product here? All right, I end up with my two ether groups. All right, so once again, how am I going to name that? Go for it. All right, hopefully you got this. 1,1-dimethoxy. I'll try it again. 1,1-dimethoxybutane. And don't forget, you also have some water. So why don't you do number 3 all by yourself? Welcome back. Hopefully you got this. So here they are, propanol and excess ethanol. And again, I don't have to make it step 1 and step 2. I just jumped all the way to step 2 because it said excess. That's your clue. So I have two ether groups. So I have 1,1-diethoxypropane and my water. So once again, oops, you know what? My H got left off. There it is. Ooh, there we are. Why don't you go ahead and do methanol and water now? All right, welcome back. Let's see how you did. This is what I got. So here's my methanol. That doesn't look right. Phew, I fixed that. Whew, good catch, Mrs. Vanderlei. All right, so I have a methodiol plus water. All right, so two alcohol groups this time. Why don't I have ether groups? Because I have water instead. I don't have any carbons on my weak nucleophile, okay? I think I got one more to go, so go ahead and pause this one and come back when you're ready. All right, welcome back. Maybe a little trick here because I have a ketone, don't I? All right, so here's my 3-pentanone. Notice how I drew it. So here's my oxygen again. So you know I'm going to have I guess I have lots of water, don't I? So I'm going to end up with a diol with water again, right? So I end up with 3,3 pentadiol. Okay, it should be 3 comma 3. It looks like I have a 3.3. So make that note for me, okay? I think that's the end of the notes. Let me check. And it is the end of the notes, so I just checked. That's it. So please practice that homework page and don't wait to be great. See you next time. Bye-bye.